Bismillah ar-Rahman ar-Rahim and Assalamu alaikum. This is Faral Javed, rule number 21TE07 from Telecommunication Engineering Department, UT Texila. So today we are going to solve lab manual 3 of digital signal processing, that is representation of unit impulse, unit step and exponential making signals out deltas. So the main objectives of this lab is basically the representation of unit impulse function and unit step function, making unit step function using unit impulse sequences and making any arbitrary signal out of deltas. So starting with the task 1, that is representation of unit impulse function in MATLAB, open editor and write the following code and save the file with the function name, that is impulse signal.m, and the output of this code will look like this. So in this code we need to observe the shift unit impulse towards the right, towards left, and multiply the sequence with the scalar values and see the effect. So basically, in order to observe the shifting of unit step sequence to the right or left or multiplying it with a scalar value, we just need to modify the input arguments of sequence function and observe changes in the output signal, that is xn. For shifting the unit step sequence towards right, we just need to increase the value of n naught in step signal. For shifting it towards left, we need to decrease the value of n naught, and to multiply it with a scalar value, we just simply need to multiply the output sequence of xn with a desired scalar. Now, our second task is the representation of unit step function in MATLAB. It's simply the same as the code above. Here we use a function that is named with step sequence dot one, and here is the output. In this code, we need to observe the unit step sequence while shifting it towards right, towards left, and multiply the sequence with scalar value and see the effect. So for shifting the unit impulse towards right or left, we need to increase the values of n naught and decrease the values of n naught. And to multiply the sequence with scalar value, we can simply multiply the output signal xn with a desired scalar. Moving towards the task 3, that is unit step sequence can be constructed by adding shifted impulse sequence, the given u of n. Use a unit impulse sequence of task 1 and construct unit step sequence. Is it possible to construct the shifted version of unit step sequence by summation of deltas? If yes, then what is required to do so? Use command pause, hold on, and hold off. So yes, it is possible to construct it, uh, a shifted version of unit step sequence by summation of deltas. The shifted unit step sequence can be expressed as the sum of shifted unit impulse sequence. The code construction, it is basically a shifted unit step sequence using a defined impulse sequence. For generating the unit impulse sequence, the shifted unit step sequence is obtained by summing up the shifted unit impulse sequence for each value of n. Then hold on or hold off command, basically used to multiple plots in the same figure and disable further plots on the current axis, etc. Moving towards our task 4, that is any arbitrary signal can be represented by unit impulse sequence x of n. Use unit impulse sequence of task 1 and construct it in following signals. Bolded number is at 0. These are the conditions and we need to plot the output. To represent the given arbitrary signal, we basically use the unit impulse sequence. We can convolve each signal with the unit impulse sequence defined in task 1. So this MATLAB code convolved three given arbitrary signals with unit impulse sequence, producing sequences representing the original signal sampled at each point. The impulse signal function generate the impulse sequence preserving the length of original signal. The resulting convolved signal are plotted on separate subplot for visualization. And yes, the output looks like this. As you can see that the resulting convert signal are plotted on separate subplots for only visualization. Moving towards the task 5, that is splitting a signal into an even and odd parts. And here is the output. The MATLAB function even odd decomposes a real signal x into its even, that is xc, and odd xo parts with represent to an index vector n. The function verifies that the input signal x is real and throws an error if it contains any imaginary component. So here is the output. The function verifies that the input signal x is real and throws an error and if it's imaginary. It then constructs the index vector m to encompass the range of both n and its mirrored version. The signal x is adjusted and aligned with an index vector m, and then the even or odd function are calculated using the formulas of an even and odd function. Moving towards our last task of today, that is impulse train can be used for sampling of continuous time signal. Use following continuous time sequence, and here is the output. So we basically define here the continuous time signal ct signal as a cosine wave with a frequency of f. And the second part is we plot the continuous time signal in the first plot. We multiply the continuous time signal with an impulse train to obtain the discretized signal. Then we plot the discretized signal in a second subplot. This discretize the given continuous signal using an impulse train for sampling. Adjusting the sampling frequencies f of s allows you to control the level of discretization. So this is it from my side. Thank you so much. Allah Hafiz.